The music you are hearing is a networked piece by Concordia Laptop Orchestra, in which the beat was generated by multiple performers, each playing a single sound on CLOrk's proprietary step sequencer programmed on pure data. Synchronization was possible through an OSC-based metronome that was broadcasting on a local wireless network. The step sequencer and OSC metronome are freely available for download at www.yaeldad.com/CLOrk. They should work equally well on all operating systems. There are other excellent tools programmed for network beat synchronization in the context of laptop orchestras, most notably ESP, programmed by David Ogborn for the McMaster Cybernetic Orchestra. This video is a tutorial on how to set up an OSC sync network and how to operate the metronome and the step sequencer, as well as how to convert the network clock into MIDI Sync, which would allow adding standard audio and MIDI applications such as Ableton Live, Propellerhead, Reason, Pro Tools, etc. to the beat-based network. The first thing to do is to download and install Pure Data, specifically the PD extended distribution, which is available at puredata.info/downloads/PD-extended. Next, download the OSC MIDI step sequencer and metronome at www.yaeldad.com/CLOrk and extract the zipped folder to a location of choice. Inside the extracted folder, double-click the file stepsequencer osc.pd on every performing computer. It should open Pure Data with the step sequencer window. Only on the computer that functions as the master clock, double-click the file oscmetronome.pd, which will open the even more colorful window with network, tempo, groove, and transport control. It is important to have only one metronome running on the network, or else some strange things will happen. The metronome sends beats, tempo, and groove information to the broadcast IP 255.255.255.255 on port 17384, a random number that could be modified if necessary on both the transmitting and receiving ends. While all computers on the same Wi-Fi network connected to the internet should theoretically receive the signal from the metronome, it is more effective and reliable to create a dedicated network just for sync purposes. This could be done by setting up a router with a local Wi-Fi network, or more easily, by creating a network on the master computer. Click the radio symbol on the Apple bar and choose Create Network. Choose a name and click on Create. Once the network is active, it should become visible to other computers in the room. If, for any reason, some of the computers have trouble connecting to the network, you may try to choose another wireless channel. Once everybody is on the same dedicated network, go to the metronome window on the master computer and click Connect, and then Start Metro. The slave computers should be connected automatically. To see whether a connection was established, check the bar beat counter to see whether the beats are counting from 1 to 4. If so, then the network aspect is set up successfully and we can proceed to explore the step sequencer operation. First, make sure that audio is set up correctly by going to PD's Preferences window and selecting Audio Settings. This looks a bit different on Windows systems. Choose your input and output devices of choice. The number of channels should remain 2 and sample rate should be 44.1. We will come back here to set up the delay time to tighten up the sync among all performing computers. Click OK. Next, turn audio processing on and bring the volume up. Now let's get a sound into the step sequencer. Sounds can be either recorded or loaded from an existing WAV or AIF file. First, let's load a click, which will also serve us in tightening the sync among all the computers. In the recorder A box, click Open Sample. Navigate to the extracted OSC MIDI Metronome folder and double-click click.wave. A single cycle waveform should appear in the array. Click the green button to hear the click. Now let's insert the click to every quarter in a single 4/4 bar. The step sequencer is arranged into 4 bars with each 16th note having a toggle button. So the beginning of every quarter in bar 1 should look like this. In order to hear the click playing, turn beat on. Now let's turn beats 2, 3, and 4 off and leave a click at the beginning of the bar only. In addition to varying network latencies, every computer has its own hardware and software delays, which may cause these clicks to sound offset from each other among the performing computers. For a tighter sounding performance, it is a good idea to modify the delay time in milliseconds to bring these clicks together. I recommend starting with 80 millisecond delay, which will allow correcting the offset in both directions. Use one computer as a reference and then sync all computers to it one at a time. This should take 5 to 10 minutes at most, and is totally worth it. Of course, any other kind of sound can be loaded into recorder A and be incorporated into the step sequencer. The other option for adding a sound is to record it from a microphone. Set the recording time by sliding the horizontal fader at the bottom of the box. Get ready and press record. I recorded a shh sound, which apparently did not start right at the beginning of the recording. For tight sync, it is also very important that the sounds used have an envelope that begins with an attack immediately when the sound is initiated. For this purpose, you can move the start and end faders to choose the window of which sound to play. Make sure that when you press the play button, you feel that it responds like a drum hit. If this is not the case, adjust the faders until it does. Listening to the sequence, one may notice a click at the beginning and ending of the windowed sound due to unclean cuts. This can be fixed with a slight amount of fade in and fade out, or attack and decay, which can be set up in milliseconds by clicking the number box, typing a number, and pressing enter. For this sound to become more like a hi-hat sound, it may need to be transposed and sped up. For this purpose, you may turn automated pitch control off and move the speed fader in the recorder A box up. To give the sounds a bit more life, you could control their amplitudes with the cream-colored fader under the toggle buttons in the step sequencer. Amplitude turned velocity here to resemble MIDI terminology, can also be randomized with the random velocity button. It can also be reset. Similarly, pitch can be automated and randomized as well. First, remember to turn pitch control on. Once the pitch is randomized, the percentage of the pitch fader's effect can be adjusted in the fader under the pitch on toggle button. You may have noticed that some clicks are introduced once the sounds are pitched down because they become longer and do not end before the beginning of the next instance. For this reason, the 16th note button was created in the recorder A box to make sure that all notes are maximum a 16th note length. Interestingly, all of these functions can be used expressively. As you may have guessed, the notes toggle buttons can also be randomized, creating random rhythmic patterns. Another interesting option is to turn automated pitch off and perform live by grabbing the pitch fader in the recorder box. The remaining 3 bars, bars 2, 3, and 4, can be utilized in 2 manners. One option is to loop 1 bar at a time and have 4 bars which the performer could jump between. For this option, leave the number of bars at 1 in the blue horizontal radio bar and select which bar to loop in the purple vertical radio bar. The number of the bar you are currently playing appears in the counter at the bottom left. The other option is to work with patterns of multiple bars. The number of bars in the loop can be determined in the blue radio bar. For example, if I choose 2 bars, every loop will play 2 bars at a time. Right now, they are set up to play bar 1 and 2, as can be seen in the counter. However, I could ask it to start at any other bar of choice. The restart button will always go to the first bar of the pattern once the current bar is finished. So for example, if I play a 4-bar pattern starting at bar 1, I can restart it at any point. Look at the counter. Having these control options allows maintaining variety in the loops of each performed sound. 2 other buttons allow some control on variation, the triplet and the double button. I will limit the patterns to 1 bar with all 16th notes selected in order to test these 2 buttons. The triplet button plays a triplet in every quarter with its first 3 toggle boxes. The double button goes into double time momentarily. The usage of both buttons is most effective in spurts in the context of a larger ensemble. Now let's view the metronome box in the master computer, which allows master control of several parameters. First, the metronome can be stopped and started. All computers will respond simultaneously. The tempo fader controls the master tempo. The shuffle amount adds a 16th based shuffle groove to the step sequencer. There is also master control of the triplet and double time buttons. And of the beat on button, which is different from turning the metronome on and off, because the beat keeps on running even if the computers are not playing the sounds. The last part of this tutorial will show you how to connect this step sequencer to any other digital audio workstation that can be slaved through MIDI Sync. For this purpose, an internal MIDI bus needs to be created on your computer. On Mac, this can be done through the internal application communication. Open Audio MIDI Setup, and in the Window menu, select Show MIDI Window. Double-click the IAC driver and make sure device is online. Under Ports, select IAC Bus 1, or Edit if it does not yet exist. If this is created for the first time, you would need to close and reopen PD in order for it to be recognized. After you do, go to the PD preferences, select MIDI settings, and choose IAC Bus 1 as your MIDI output. Now open an application of choice. In this tutorial, I will use Propellerhead Reason. Set the application up to receive MIDI from IAC Bus 1, and make sure it knows to receive CLOrk from it as well. Turn on MIDI Sync, which will put the application in slave mode, awaiting MIDI CLOrk from another source. MIDI Sync includes MIDI commands SPP, or Song Position Pointer, which tells the sequencer where to start, SSC, Start, Stop, Continue, which is basically transport control, and MIDI CLOrk, which provides 24 ticks per 1 quarter note. In your step sequencer window, set up the beginning bar in the MIDI Sync window. Press Start. You may change the tempo in the master sequencer and see if it affects the MIDI signal. Be aware that whenever tempo is changed, it restarts the sequence at the beginning bar. It is also necessary to set up the correct offset to tighten the sync with the MIDI content. Do not change the delay setting in PD audio preferences. Instead, add offset in the MIDI Sync window. The PD audio offset and the MIDI Sync offset are independent of each other. Stop and start MIDI after you do so to make sure the change is applied. Use a simple pattern for sync and do your best to tighten the two sequencers together. It's easier to do so in slower tempi. MIDI Sync may be a bit unstable at times. If it feels this way, you may always stop and restart the MIDI clock. You can do so even just for interest's sake, while changing the beginning bar's number. Using MIDI Sync in this tool allows using much more sophisticated sequences as part of the laptop-ensemble, as you can hear in this Concordia laptop orchestra performance. So that's it. Your ensemble should be set up for wireless sync. I hope you like it, and please send your comments to my email, tsabarytools@gmail.com.